So far, we've been estimating the areas under a curve with left-hand Riemann sums and right-hand Riemann sums. The third technique that I want to show you about is called the midpoint technique. And once again, a lot of the clue is in the title. So we're going to do the same thing we've been doing before. We've got the same curve. This time I'm going to use the same three rectangles that we've been using. But this one is called the midpoint technique. So I wonder, can you guess how we're going to determine the height of these rectangles? Well, we're going to use, instead of the left-hand corner or the right-hand corner, we're going to use the middle of the rectangle to determine the height. So halfway between 1 and 3 is 2. So this right here is going to be the height of my first rectangle. Okay, and the same thing, I'm going to use f of 4 for this rectangle and f of 6 for this rectangle. And same questions I've been asking up to this point. How good of an estimate is this? And do you think it's going to be an overestimate or an underestimate? Well, this one looks like it's really close. So these two and these two errors in my estimate look like they're going to balance each other out really closely, and these two as well. So I am looking forward to this being a really close estimate. I don't know. If I had to guess, I'd think maybe it's going to be an underestimate. I'm sorry, no, I think it's going to be maybe an overestimate, because I think this is just a little bit bigger than this one. And this is a little bit bigger than this one. And this is, well, these are quite a bit bigger than the other one. That's pretty clear. This one's a lot closer, but I think it's going to wind up to be an overestimate, but certainly not as bad as what we've been measuring up to this point, which is a nice side benefit of the midpoint technique. Not so good at determining upper and lower bounds, but really strong at figuring out a close estimate. All right, so once again, the width of all of these rectangles is 2. What are the height of these rectangles? And what do you think our strategy is going to be for expressing them in terms of f? Well, as we said, this one is f of 2. This one is f of 4, and this height is f of 6. So this is a midpoint Riemann sum. And so, I don't know, 2 times f of 2 plus f of 4 plus f of 6. So maybe the way you'd want to think about it this time is we think about all of the corners that we were counting with the first two techniques. We start at 1, we end at 7, because those are our bounds. We're counting by 2. So 1, 3, 5, 7. And instead of using these 4 numbers, we use the numbers in the middle. And then multiply that sum by the width of the rectangles that we're using. So let's pull out our table. And as I say, this should be between the two estimates we've been gathering up to this point. 7.67 plus 7.67 plus f of 6 is 5. We multiply that by 2, and we get a total estimated area of 40.68 from the midpoint Riemann sum. Okay, so that was the technique for doing midpoint Riemann sums. And what I want you to do is I want you to take that technique and apply it on the next diagram, which will be midpoint sums, except you're going to be taking 6 rectangles instead of 3. But you're going through that same technique. You're going to be using this same table, and you're going to come up with what you might think would be a better estimate than the 40.68. So give that a shot. And in the next video, we're going to talk about the fourth and last technique we're going to use to estimate areas using Riemann sums.